All right, so summary from this. Square root a big number, you get a smaller number. Here, really important, square rooting 1 and square rooting 0, stay the same. And then anytime you have a number between 0 and 1, when you square root it, your answer is bigger than what you started with. So, this is called a rational function. Take out your highlighter, or not a rational function, a radical function. When you take anything you've ever done and throw it inside of a square root or cube root, but we're going to deal with square roots. Okay? Now, we've already done the simple square root graph. That was one of our parent graphs. You know that that graph looks like that. But now, what we're going to do is we're going to develop a different strategy for not only that'll help us graph what we already know, but also help us graph other things as well. And the strategy looks like this. We'll start with the square root of x plus 4. You can graph that already, because what would you do? You would take your regular square root graph with key points, there's my 3 key points like this, and you would just move it over 4 units, because it's a transformation. 4 units to the left. Perfect. And if that's how you graph square root of x plus 4, I'd be extremely happy, because that's exactly what you should do. But now we're going to look at learning a new technique. And the new technique says, what happens if first you graph just the inside? So in red here, they graphed just the inside, y equals x plus 4. And you know how to graph that because it's a straight line with a y-intercept of 4. And then you take the graph that you already know, the inside, and you use the patterns we noticed in our first activity. Wherever you have 0 and 1, when you square root it, it won't change. So does that make sense that when the red graph, the y value is 0 and the y value is 1, then if you square root it, you would still get 0 and 1. When you square root bigger numbers like 4, what happens when you square root 4? That's easy, it's going to be 2. And everything that is bigger than 1 is smaller than your original graph. But everything between 0 and 1 is slightly bigger. And we get the same square root graph with the same 3 points with a different technique. And where this is going to be nice is you might be asked to square root an x cubed graph. You might be asked to square root a log graph, square root a sine graph. Any graph that you're like, oh, yay. Any graph that we've done so far, we can now square root it and graph that. You're like, oh, just what I was hoping for. Another unit on graphing. We haven't had one of those for at least 10 minutes. So, here's another one. And this one I really like, because I think the new method is better than the old method. So I'm going to talk about if you were asked to graph this. You could choose the old method or the new method. The new method I'll do first because I think it's the easier one. You graph the inside. Do you see the inside is a line with a y-intercept at 2 and a slope of -1. So this is the inside graph in red. Then the square rooting of it says, can you find where it's equal to 0? On my red graph, it's equal to 0 right there. Can you find where it's equal to 1? It's equal to 1 right there. Square rooting 0 and square rooting 1 stay the same. If you square root a bigger number, and sometimes I actually go through and look on my red graph and I'm like, oh, here's a nice 4. Because I can square root 4 in my head really easily. Square root of 4 is 2, so on my blue graph I have that place. Whenever your y values are bigger than 1, square rooting makes it, wow, that was so bad. it's going to be smaller. Do you see my y values are less than my red graph there? But between 0 and 1, when you square root a number between 0 and 1, your blue graph has to be slightly above your red graph. Because square rooting a number between 0 and 1 makes it a little bit bigger. Why do I say this is a better method than our old method? Okay, let's talk transformations. What is the negative? Horizontal or vertical reflection? Whew. See, this is already we're struggling. That was the easy part of the question. Hint, you're not supposed to struggle yet. It's coming. Inside would make it a horizontal reflection, right? And then the +2, also inside the square root, it's going to be a horizontal translation. And x's are liars, so you see the +2, and you might think 2 to the left, but this is one that when you have a horizontal reflection and a horizontal translation, you would have to first remember that you have to write it in factored form. So we still have our horizontal reflection, but our horizontal translation should be 2 to the right. So our normal square root graph, right? Draw quickly. There's our normal square root graph. What happens to it? Horizontal reflection goes over here. Then we need to move 2 to the right, and it matches up exactly with the final graph. But I think in this situation, the new method is way better. Because can you see yourself forgetting to factor out? Yes, I see it all the time. Every time I ask you that question. There's never been a question with the factoring thing that somebody in this class hasn't forgotten. But the new method just says, hey, graph the inside and use the 3 main ideas. 0 and 1 stay, there's actually a 4th main idea. I'm going to talk to you in a second. But the 3 main ideas we've talked to so far. 1, 0 and 1 stay the same, always when you square root. 2, if you square root something bigger than 1, it's going to be smaller. So you can make it smaller, and you can find any nice points that you can square root and label them. Like square root of 4 is 2. If you have a 9, you can square root of 9 is 3. And then idea 3, any number between 0 and 1, when you square root it, it gets bigger, so our graph is slightly bigger. And the 4th rule I haven't talked about is this part. Why did I stop the graph and not do anything here? It's not possible, right? Because that's where your y values are negative. Can you square root a negative number? No. So that becomes impossible. Okay, so with that, we can go to... Oh yeah, well, we talked about these. We don't need to highlight them. I don't feel like highlighting them today. Sometimes on the exam, they'll say, do you know the idea? And we just give you a random graph even though you don't know the equation. This is technically an easier question because the harder question would be you'd have to get the equation and you would have to graph the inside of the line first. So if I was making this a harder question, I would get you to graph y equals, can you see that this is 2x plus 4? And if I got you to graph this, that would be a harder question because you'd have to draw the line yourself. An easier question, they draw the line for you, and now you just have to do the square root part. So the 3/4 main things for drawing a square root graph. I always start with 0 and 1, because square rooting 0 and square rooting 1 stay the same. So I look at my y value of 0, put a dot there. I look at my y value for 1, and sometimes your y value, you won't even know what the x is. Like, looks like minus 1.5, but I don't know for sure. Maybe it's off a little bit. Then I look if there's any other nice numbers I could square root. Are there any other nice y values you could square root? Well, here's a 4. What's the square root of 4? That's 2. 9 seems to show up. I'm going to put it on there. 9 is about here, that's going to be 3. See how I got those points? I took y values that were easy to square root, and I square rooted them. And so that tells me that this section here is going to go like that. Then, the section between 0 and 1, you have to make it slightly above. And often there's like hardly any room to do that. There we go. I can just barely go slightly above. Because if you exaggerate, I'm going to take out orange to exaggerate. Okay? What's wrong with this? Okay, that's really exaggerated. What's wrong with that? I'm above. I just want to make sure. It's like I went back in time. You see how, thank you. There doesn't exist anything when the x values are negative. I went back in time. And you can lose a half a mark on the exam if your exaggeration goes back in time. That might be enough for them to say you exaggerated it, because I went backwards and came forward again. So drawing that, it is important to make sure that you don't go back in time. Sometimes you'd be like, how do I show that? There's no room. Then if there's no room, just draw it like almost right on top, a tiny bit above, it'll be fine. We'll look at some, I think you did some today, like there's no room. So if you went to part B, the steps for, I didn't finish part A. Do you see that it says, sketch the graph, we did that, state the domain and range of the blue graph? So the domain is the x values are bigger than or equal to -2, and the range, the y values are bigger than or equal to 0. That's for the first one. Second one, I'm square rooting a graph. I look at where's my y value 0? Where's my y value 1? Those will be the same. Do I have any nice points? I don't actually. Like, can you see that if you kept going, you would hit 4 right about there? So if you wanted to, you could say, okay, I know the 2 is going to be about there. Does anybody know what the square root of 3 is? 1.7, 1.73. So you could, if you knew that. Does anybody know the square root of 2? 1.4. So if you knew these other ones, here's 1.4, you could put them on, estimate. But we see that when the original is big, a big number when you square root gets small. And between 0 and 1, so between these two dots, here our graph has to be slightly above. Also exaggerated, that would be bad. Slightly above and going over 1. Yeah, not good. So you kind of want it to be smooth in the end for your curve. So that orange is that exaggeration. All right. And someone says, so what if I struggle with making things neat? I have the inability to make it neat. That's fine. I just have the inability to give you full marks. It's like, forgive me. Try to be as neat as possible. So our domain for this one, x is less than or equal to 6, and our range is still bigger than or equal to 0. Questions you can circle on this one. This is question number 5.